These are the broad categories for hydrocarbons. What we discussed in nomenclature: alkanes, alkenes, alkynes, they come to aliphatic category, and because of the unusual stability of benzene, and there are several compounds that are benzene type, they belong to aromatic category. Within aliphatic, we have saturation and unsaturation both. If you find no pi bonds, saturation, that is alkane. But if you do find one pi bond or more than that, that means unsaturation. Alkene, alkyne. Now in this context, I would also like to say that in case of cycloalkanes, while there need not be any pi bond, but still it gives rise to somewhat of unsaturation characteristic. Just think of propane and cyclopropane. You don't find any double bond in cyclopropane. But if you count hydrogens, you find it is just like alkene, formula-wise, but no double bond. And cyclopropane is enormously more reactive than just propane. So without pi bond also, there can be some visualization of unsaturated characteristic. But normally when we use the word saturation or unsaturation, normally, that it may have to do with pi bond or no pi bond. Alkyne obviously has greater unsaturation. Pi bonds are known for addition reactions. So whenever the word unsaturation comes to your mind, always think of addition reaction. Then aromatic. So that ring type of pattern. And there can be several derivatives, so it's a huge family. Now there is no oxygen, there is no nitrogen, or there is no other element that has significantly different electronegativity from carbon. That's the story of hydrocarbons. No other element is present that has significantly different electronegativity from carbon. So the question of polarity is gone. And many things depend on polarity. Intermolecular forces, for example, very major point, intermolecular forces. And if there is no polarity, how does a Coulomb law going to work then? How would molecules attract each other or would attract some foreigners? So there is absence of polarity here. Now, what about the reactive site? Well, what else except hydrogen? We have talked about functional groups in nomenclature. So when we say alcohol family, there is a reason. When we say aldehyde family, there is a reason behind saying so. Because OH group, or because CHO group, or because COH group. These groups are assigning some characteristic to the family. So that's what the concept of functional group is about. When you learn periodic table, you learn it the vertical way. I mean, when you learn properties of elements, then you look at it the vertical way in periodic at periodic table, because there is some similarity the vertical way. So just like that, think of organic chemistry as some group-based approach. Just like a column of periodic table, here you have several groups. In alkane, well, what else except hydrogen? So in alkane, you don't really expect it to be very reactive. Combustion reaction, yes, that's one of the key reactions actually of alkane. For us, energy. Alkanes give us energy. And chemically, if you speak, then there is substitution reaction also, in which you are able to replace hydrogen atom by somebody else. It could be chlorine, it could be bromine. After that, it suddenly becomes very interesting. There is a huge chemistry of alkyl halides. So once you have alkane, chemistry is limited. Mostly we talk about combustion reactions giving us energy, or we talk about substitution reactions. But the moment you have, after substitution, alkyl halides, halogen introduced in place of hydrogen, it becomes a huge chemistry. Chemistry of alkyl halide is a huge chemistry. So hydrogen atom can be replaced by somebody else. And this type of characteristic is shown by benzene also. Now we were discussing, I think earlier, that why not hexatriene, benzene? Why not hexatriene? Well, alkenes are not known for substitution reactions. Alkenes are not known for substitution reactions. And benzene gives all sorts of substitution reactions. So in one example below, you are seeing that hydrogen is replaced by chlorine, and there you are, alkyl halide. This fellow is very important, this group rather. So functional group, alkane hydrogen. When you have unsaturation, then that gives rise to reactivity. Pi bond is a weak bond. And it is also something that gives rise to electron richness. Imagine two bonds located between two carbon atoms, two bonds. One is sigma, one is pi. That effectively means that 4 electrons have got a colony there, 4 electrons. And if you have alkyne, then it means there is 1 sigma and 2 pi. 6 electrons have got a colony there. So invaders are interested in that colony. The fellows who like negative charge density, they are interested in those colonies. So in case of alkenes and alkynes, that becomes the point of interest, double bond or triple bond. In case of aromatics, arenes, it is just that ring We already have talked about key functional groups while discussing nomenclature. So I'm skipping that part and concentrating on alkanes. The general formula is CnH2n+2. Smallest three members are methane, ethane, and propane. After that, we have got some problems. Before we talk about that problem, look at the order of boiling point. Just look at the order. Minus 100 degrees centigrade, let's say. That range we are talking about. So imagine if you want to get liquid ethane. If you want to get liquid ethane, then you have to reach somewhere near minus 100 to get liquid ethane. And look at water. Even at plus 100, it is liquid, just turning into steam gradually, if there is heat. And this fellow minus 100. So the answer to these things lie in polarity. Answer lies in intermolecular forces, basically. Answer lies in just one single law called Coulomb's law. Organic chemistry is all about Coulomb's law. All reactions. And not just the chemical reactions. Physical properties are also about Coulomb's law. Physical properties, chemical reaction, they are all about Coulomb's law. So water plus 100 liquid. Ethane, if you want to get liquid, you have to go at near minus 100, roughly speaking, let's say. The answer lies in polarity. And in polarity, it's important to mention hydrogen bonding. It's very important to mention hydrogen bonding. Because if you look at something like ether, that also has oxygen. So it has got polarity, but you find vast difference in ether and alcohol. Ether versus alcohol, vast difference you find. Both have got oxygen. The difference is hydrogen bonding. So polarity is the key, yes, but in polarity, when it becomes involvement of hydrogen, that becomes especially very important. And in case of water, you have that thing very much, hydrogen bonding. So the answer to these low numbers is in intermolecular forces. Intermolecular forces. After all, what is the idea of boiling? Just take molecules far away from each other in vapor phase. Far away from each other. If they don't attract each other strongly, so easy it would be to take them apart from each other. So in case of these fellows, the attraction is very weak. How one molecule attracts another molecule, that is very, very, very weak. There is absolutely no polarity because carbon and hydrogen are almost equal in electronegativity. So no polarity. So what choice, what options are there now? Induced dipole? Induced dipole? What is this induced dipole? Any answer? Think of it like this. Induced. Dipole is induced. So when we say some molecule is polar, it means plus and minus are different. I mean, at different places. At different places. They don't sit over each other. So you say that it is a dipole. However, if plus minus sit over each other, then it's a problem, not a dipole, not a dipole. But then, atom is not really a coordinate, very strictly speaking. Atom is not just a coordinate, because in that atom there is a nucleus and there are electrons revolving as well. Yes, it is the motion of electrons. It is the motion of electrons that is the key. Now if you find that electron cloud is symmetrical like this, if you find electron cloud is symmetrical, then it is like saying that plus and minus they just sit over each other. If electron cloud is like that, but then electrons move and it's possible that such a nice distribution may not be there. You know, electron motion, probability, all those things. So suppose due to the motion of electron at some instant the density becomes larger, electron density becomes larger here. And electron cloud is deformed like that. In physics we talk of center of mass concept. Here think of it as center of charge concept. For this ball I can take center of charge here, but for this I can't take center of charge here. I would have to take somewhere to the left. And there you are. Now minus does not fit over plus. When minus does not fit over plus, now you have got a dipole. And when you have a dipole, then it can influence others. For example, imagine I shift that minus charge to the left. Plus is on the right, minus is on the left. Minus is on the left because of this deformation. Now, when they are at different distances, won't they influence electron cloud here? Electron cloud will be closer to positive and farther to negative. So won't electrons feel a net attractive force? Coulomb's law works better if distances are less. If with plus distance is less, with minus distance is more, attractive force becomes more, repulsive force becomes less. So now electrons get deformed here. So this minus comes to the left. And see what happens here. It was not a dipole. Minus was sitting over the plus. Now it is a dipole. And you have a chain reaction type of thing happening. But this can't be permanent. It all happened because of movement of electrons. And electrons are continuously moving. So it can't be permanent. So it is instantaneous type of thing. Came and gone, came and gone, came and gone type of case. It is seen that, it is found that these types of forces are more when there is large surface areas involved. If you find two huge molecules, imagine C20, for example, C20, hydrogen 42, then imagine one over the other. So when you imagine something like C20 and hydrogen 42, one molecule over the other molecule, two snakes, imagine two snakes. Such a large area they have if they are side by side. That's where you find that this type of force plays significant role, not for small fellows. Not for small fellows. These numbers tell you the story, how poor it is. Minus 160. All right, we stop now.